Hi guys, so I've seen that a few of you have been a little bit confused about this sheet where we are working out the relative atomic mass, the atomic number, the number of protons, the number of electrons, the number of neutrons and the overall charge of our atom. This is where we really need to make sure that we have a periodic table. This periodic table is the one that you will get in your GCSE exam. Okay, so the first thing we'll be looking for is hydrogen. Hydrogen has the symbol of H. We have the relative atomic mass. Now if we have a look, we've got the relative atomic mass here in the key is at the top, so that means it's the top number. So for hydrogen it is 1. We then have the atomic number as the bottom, so for hydrogen here it is 1. The atomic number is the number of protons. So because hydrogen has an atomic number of 1, it's got 1 proton. The number of electrons is the same as the number of protons. So that means as it's 1 proton, there's 1 electron. And the number of neutrons is the mass, relative atomic mass, take away the atomic number. So here it's 1 take away 1, which is 0. So there are no neutrons. Okay. The overall charge, well, each proton is +1, each electron is -1, so that means that we've got +1 and a -1, and those cancel each other out. Okay, helium, we had all of these things filled in. We've got 2 protons, 2 electrons, so 2 +1s and 2 -1s, so those cancel each other out. If we have a look for lithium over here, we've got Li. Note the capitalization, it has to be the same capitalization as appears on the periodic table. Okay, otherwise you won't get the marks. Okay, the relative atomic mass at the top, so 7. Atomic number at the bottom, so 3. That means 3 protons. Electrons are the same as protons, so 3 electrons. And then we're going to do 7 minus 3, so we've got 4 neutrons. Because protons and electrons are the same, again it has no charge. So we're going to look at beryllium next, so that's Be. And we've got a relative atomic mass of 9 for the top number, atomic number of 4, so that means 4 protons. Electrons the same as protons, so 4 electrons, and then we're going to do 9 take away 4, so that gives us 5, and again we've got the same number of protons and electrons, so their charges cancel each other out. Then we're going to have a look at boron, so that's capital B. Relative atomic mass is 11. Atomic number is 5, so 5 protons, 5 electrons, and we're going to do 11 take away 5, so that gives us 6 neutrons. And again, no charge. Carbon next. Relative atomic mass of 12, atomic number of 6, so 6 protons and 6 electrons, because those are always the same. And then we're going to do 12 take away 6, and that gives us 6. And because we've got the same number of protons and electrons, we have no charge again. Nitrogen now, capital N. It's got a relative atomic mass of 14, atomic number of 7, so 14 and 7. So 7 protons, 7 electrons, 14 take away 7 is 7, so 7 neutrons in this case, and because we've got the same number of protons and electrons, we have no charge. Next we've got oxygen, capital O, relative atomic mass of 16, atomic number of 8, that means 8 protons and 8 electrons, because those always are the same in our atoms. We're going to do 16 take away 8, because remember it's the relative atomic mass take away the atomic number, because this is the number of protons and neutrons added together, so to get the number of neutrons we do the number of protons and neutrons added together, take away the number of protons. 16 take away 8 is 8, and because the number of protons and electrons is the same, they cancel each other out, their charges cancel out, and we end up with a neutral atom. Fluorine then, capital F, relative atomic mass of 19, atomic number of 9, that means 9 protons and therefore 9 electrons, and we're going to do 19 take away 9, so we've got 10 neutrons. Because we've got 9 protons and 9 electrons, their charges cancel, and we end up with 0 charge. Neon then, the last one, which you can still see, so Ne, capital N, little e. relative atomic mass of 20, atomic number of 10, that means 10 protons and therefore 10 electrons. 20 take away 10 is 10, so we've got 10 neutrons, and of course because the number of protons and electrons is the same, they cancel each other out. Hopefully that makes sense as a set of answers. Okay, if you need to check yours, check it against that. Hopefully that has helped.